Now very quickly, a capacitor. Would consist of two parallel plates, okay? And from an end view, the plates might look like this. Okay, one plate is positively charged, one plate is negatively charged. And the way you get that to happen, if these are metal plates, you generally pump electrons from this side to this side. Okay, you can do that, shuffle your feet across a carpet. You know, we did it, you know, with the PVC pipes. I didn't show you the capacitor yet, I gotta wait for a sunny day. Okay, but, you know, we do that with a generator, a battery, whatever, okay? We can transfer charge from here to here, which then gives us an electric field. We have the electric field, let's say from the positive plate, the electric field will be away from the plate. From the negative plate, the electric field will be toward the plate. So what's the result? Well, the result is that between the plates you get a lot of field. Outside the plates, the two fields tend to cancel. You're going to have the electric field of the positive plates tending still in this direction, right? If they're big plates, the field doesn't diminish with distance. Notice that the field here has no distance involved. I never had to assume a specific length of this thing. If it's an infinite plate, the field permeates all space and is uniform. Okay? Now, the same would be true if, let's say, this board was the plate, as long as you stay much closer to the plate than you are to the edges. Now, there are integrals I ask you to do here that'll prove that. Okay? Okay, so if you add up everything here, what you end up with is pretty much a strong electric field between the plates, away from the positive and toward the negative, right? And pretty much zero field outside the plates. Okay? Not strictly so. If you're really close to the plate, you do get some electric field on the outside, but not much. And we'll test that. You know, we'll charge up one of these things. Hopefully it'll be sunny on Friday. So that's what we have, right? Then we have the question of, okay, what if I'm pumping electrons from here to here through a resistance? I can only pump them at a certain rate. I only transfer charge at a certain rate. So I don't instantly get full charge in this thing, okay? But I do get a voltage between here and here because I got an electric field over a distance, okay? Then I ask you to work that out. Well, what happens is the more charge you build here, so let's say you're pumping this with a battery, okay? The more charge you build, the more this resists the transfer of charge, because I'm transferring electrons from here to here. The more electrons I got here, the less current flow I'm going to have if I'm using a battery. I get a voltage that acts in the direction opposite what the battery does. And that leads me to a very simple differential equation. Okay? So I asked you about that. So do what you can with this. You know, especially work on those integrals. We'll get more into this next time.